All, I would say, not the next thing.
Okay, folks, we'll crack on. Okay, so what we're gonna, so obviously there you are sending stuff back. It's just in the three of them. So the first one was a shifted. It was like 12 over s squared. So the first one, it was like 12 over s squared, which you can send back using that, except it was shifted. And when it's shifted, instead of s, you have s plus a. In your case, instead of s, you have s minus 1. You have to bring back the 12 over s squared as normal, and then multiply it by the exponential shift, which for you should have been e to the t, or e to the 1t. Okay, or e to the minus 1t, if you really want it. The second one, you just had to do a manipulation, divide it above and below by 4, and get it in the form s over s squared plus a half squared. Did we use k's, is it?
Yeah.
So this is a cos kt, and the last one wasn't in the tables. So what you have to do is you have to write the sum of simple things that was in the tables. You have to do partial fractions, and the first thing you have to do is factorize the bottom. It was s minus 10, s plus 10, and then you, now they're 2 rule 1, so you can do cover up method. When you have them set up, you can bring them back like so.
And why couldn't we just write the same as the one before, you know, s squared as, and the 100 as 10 squared instead of minus 100?
Because it's plus. Plus. You had minus. That's right.
That last one, just take 3 from the top of the line, bring it out.
You can, but you still have to do cover up method with s over s squared minus 100.
And the second one, you couldn't take away the bottom s squared, because we did 4s over 4s squared, and just give it 4s.
Say again?
Second one, you had above the line, you had 4s, below the line, you had 4s squared.
Yeah.
So you put that as 4s, equate 4s on top, and you do 4s plus 1. There's something in the form, is that right? There's a...
No, not like, no, you have to divide above and below by 4. So to get to s over s squared plus 4.
Yeah.
That's what it's got.
Why, can you explain why squad? I don't get why.
Well, if you have two numbers, or if you have a fraction, right, you are allowed to divide above and below. Because you can divide above and below by 4 by multiplying above and below by a quarter. What's that you keep Sorry folks, when someone asks a question, everyone should probably... What's that you keep that? 1. Multiplying by 1 will make no difference. So multiply that in a quarter of 4s squared is s squared, a quarter by 1 is a quarter. Okay. Now we're going to see a few more sending back. We're going to see, there was one I emailed to you that was a bit longer and probably longer than what you'll have to do in the exam, but there are hard ones that we're doing. Now it's worth us doing them. Definitely, like we have to cover them. They're the most interesting ones as such, and they are going to be in quiz 13, but they're kept more or less, I'm being very nice, they're off as a full question off the exam paper. Now a part of them you I have to be a little careful when I say, I'll have to get back to you a little bit on that exactly. Now there's a full question that we'll get to tonight that won't be as hard as it can be on the exam paper. That's what I promise you. Okay. So this is so at the moment we're still just focusing on sending stuff back, and then tonight we're going to do a full question where you start with a differential equation, turn it into an algebraic equation, find the Laplace transform the solution, and send it back. So we're on page 116, and this now is about, this is hard. This doesn't look that scary, but this one is going to be very hard. Okay, so you want to send this thing back. So you look in the tables and you say, is there anything like that in the tables? And you would say, no, there's nothing like that in the tables. So maybe you can write it as a sum of simple terms that is in the tables. So maybe you can do a partial fraction expansion. This is page 116. Okay, and the first step in doing a partial fraction expansion is factorize the bottom.
I was skipping the other one, Jay.
Yeah.
I emailed it to you.
Oh, you emailed that to us.
No, you
Oh, I didn't, sorry, excuse me.
read number 4, right?
Okay, yeah, we'll just go back and look at this one. This is a good one for the exam paper anyway. Sorry, I don't know, but I think so. Okay. Well, no, I mean, it's probably likely. I don't remember everything I put on it. Okay, so we'll go back to this horrible one in a second. This one is not too bad. Now, the big thing is we're good with sums. So, for example, with partial fractions, we want to write that as a sum of simple things that's in there. So this thing as is, we can't really send back. There's nothing there. You can't just send back the 1 over s to the 4 because it's multiplied by other stuff. It's not on its own as a sum. So is there any way you could turn that into a sum?
Yeah, expand out the task then.
But so multiply out the top. Now that should be okay for us. So you're going to have s by s is s squared. S by 1 is s plus 1 by s. So you get s plus s is 2s. And 1 by 1 is 1, all over s to the 4. And when you have a sum, there's different ways of explaining this, but say, for example, or the easiest way is if you find 20 quid and you find 100 quid and you're sharing it with the person who saw you pick it up off the ground, you can share the 20 and share the 50 separately. So this would be 20 divided by 2 and 100 divided by 2. So I would maybe let's write it like this. 20 over 2 plus 100 over 2. So when you've got a sum divided by a single number, you divide all of them by that number. So we're going to have s squared over s to the 4 plus 2s over s to the 4 plus 1 over s to the 4. Now, there's various ways of kind of simplifying these. If you're a bit too wedded to rules, you'll kind of end up in a little bit of problems. Like, probably what will happen if you use rules is you'll probably end up with, what do you know about, it'd be nearly good if you don't remember rules here.
I explained about no, what that was again, it's s squared minus the, to the first one, s squared minus the s2, so it's 1 over s2.
Yeah.
And then take 2 over.
Yeah, you're dead right. How do you do that?
Google this.
Now, so basically, there's different ways you can do it. The way you're kind of trained, well, to be honest, you probably weren't trained because most of you didn't do the Math 6000. But in the Math 6000, you end up with, when you divide like you subtract, you end up with s to the minus 2, and you look over here and you're possibly in trouble. It's a bit better just to say, well, I'll divide above and below by s squared on the first one. What's s squared divided by s squared?
1.
Right, and then s to the 4 divided by s squared,
s2.
s to the 2. So that's kind of the easy way to think about it. And the next one you divide above and below by s, to get 2 over s cubed. And the last one, well, the last one's ready to go. The big idea is you're good with sums. Now you have to do a little bit of algebra, 2 bits of algebra, 3 bits of algebra to get it in the form. 3 bits of algebra to get it in the form ready to go. And now you can send each of them separately. So if this is big F of S, I can send it back to little f of equal to I might just... So you're kind of maybe looking at this and you say, I don't want the s squared there. So you divide by s squared. And if you divide the bottom by s squared as well, you're fine. What's that red thing equal to? The red thing?
The right hand side, that's 1, is it?
Yeah, 1. So multiplying by 1 doesn't change it. So I can write equals, and then how do you multiply fractions? Top, top, bottom, bottom. So s squared divided by s squared is 1. S to the 4 divided by s squared is s squared. So that's what I did on the first one there. Now we can send this back, each of them separately. So 1 over s squared. So we'll go back to t to the 2 minus 1, t to the 1. Over the same thing factorial. Plus fix the 2. Now the s cubed. Go back to t squared. Over the same thing factorial. And then the 1 over s to the 4 will go back to t cubed over the same power factorial. And just tidy it up. T to the 1 is just t divided by 1 factorial, just 1. So t divided by 1 is t. 2 factorial is 2 by 1 is 2. So 2 divided by 2 is 1. So you get t squared. And 3 factorial is 3 by 2 by 1, which is 6. If you ever kind of forget those, they are actually on your calculator, those factorials. I said something like that. I don't know if there is something like that in your exam paper, but it's likely.
I don't know, JB, do you know, just actually, there was something that you mentioned about the previous thing there. Do you know, the top of that line was s plus 1 squared, and you multiplied that. In the exam, it was below the line, with s minus 1, which gave us
That was a different thing.
s squared, plus 2s.
But okay, so this
But
is
you know, sorry, but you know how I was 12 over that, and we had 12 over 1, so it was negative 12 at the end of it. What happened to that constant? I know you showed it there briefly, just at the very start.
12?
Yeah, because it was 12 over s negative 1 to be squared, you know. That was the exam question.
Now that's just a shifted 12 over s squared.
Yeah.
Okay, so if you're really worried about how to
Well,
really
it was actually s minus.
I know that, but it was a
Alright,
shifted
yeah.
one of these.
Okay,
I
yeah.
think you have to handle this first.
Okay.
So, see the way, like, I mean, you could say the way I brought the 2 out, where did I? Well, I didn't do well. How do you deal with that constant, basically?
Yeah, that's 2 by 1 over s.
Yeah.
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 But I understand, like, but there was part of the transform in there when your s minus 1 squared, when you multiplied that out, you were actually left with 12
Don't
over s
multiply it
squared.
out.
Or you don't multiply it.
Never multiply out the bottom, ever. The only time you're going to multiply out the bottom is if
Oh, so
it's not factorized.
All right. So,
it's already
so we'll
factorized.
always treat it if it's squared or cubed. We'll always treat it that it's
Yeah, well, if it's one of
minus
these,
1 or minus 2 or whatever. It's just the first.
it's just a shifted one. Yeah, it's very, very rare in maths in general that you'll multiply the bottom out, because now there's some weird cases, but most time you don't. Like, say you want the bottom to be factorized, like you don't want to multiply it out. We're very good at I was up here a minute ago, or here. We're very good at taking sums and dividing them, but we're not good the other way around. Dividing by a sum, we're crap at that. So, yeah.
Sure.
Okay, so that's that. So we'll go on to this. So this one is, as I said, this is horrific. It doesn't look good. It doesn't look scary, but it is, right? So now the bits I'm saying here, you have to understand. Okay, we want to send this back. We're looking in the tables. It's not there. That kind of looks like it, but there's an extra 6s knocking around. You can send it back using the tables. So you want to do a partial fraction expansion to write this as a sum. So, and the first thing you do is you factorize the bottom. So we take our s squared plus 6s plus 13, and we try and factorize it. So I'll multiply, we're calling this the AC, you multiply the 1 by the 13, and look at all the factors of 13, so you get 1 by 13, 2 doesn't go, 3 doesn't go, 4 doesn't, nothing else goes. Can we make up 6 with this?
No.
No, so this has failed. Now what this means, what were we saying?
No, it's the 8 squared.
Yeah, okay, yeah, you're right, basically, now this means that you can factorize it using nice numbers. Now in the wild when you're doing this in an actual application, this is normal. You don't have nice numbers. It could happen that this has factors. It's just a horrible, right? Now that's not going to happen with us. If this doesn't work, then this has no factors at all. But just to double check, if you look at the b squared minus 4ac, and if we think back, we had, where did I write it? Right here. We had this little factor theorem. K is a root. That, say for this, k would be a number that you bang in and get 0. Is equivalent to saying, in this case, s minus k a factor. So if you can find a root, if you can solve it equal to 0, you automatically have a factor. So this method, this AC method, is not working, so we can try instead to find the roots. And the roots would be solving this equal to 0. If you can't factorize it, you have to use the minus b form. So you go and attack this with the minus b form. And now the only thing I really care about is the b squared minus 4ac. That's inside in the square root. And if the thing inside the square root is negative, a complex number, you don't have any roots. And if there's no roots, there's no factors. And then then it's bad. Okay, so b squared minus 4ac here is 6 squared minus 4 by 1 by 13. It's 36 minus 52. It's certainly negative, and that means no roots, which means no factors.
Where did you get the b squared minus 4ac?
Do you know that the formula for yeah,
The minus b form.
the minus b formula for solving? Say the s squared plus 6s plus 13 is like ax squared, 1x squared plus 6s. Well, we've been using it here and there in terms of the exam, but right, that's formula that you can, I suppose you can use it.
Is it going to be on the sheet?
No, you need to know. That's supposed to be. I can write it up I can write the formula in week 13. But I'm going to be writing the full formula, not just b squared. You have to know where that's coming from. So it's got no roots. So no roots, there's no factors. That's bad. Really bad. Because it means you can't do any partial fractions. Like if you want, you just say, well, this is just a rule 2. And a rule 2 is, it's going to be bs plus c over this, but you've already got the b and the c. So the partial fractions is already done. There's nothing more you can do to simplify it in that sense. So again, you look back at the tables and you say, well, what does it look like? And it looks maybe a little bit like this. You see you have the s on top, you have an s squared and some other stuff. And maybe it also looks a little bit like the sign. Because you've got a constant on top, s squared and some other stuff. Right? Now see if you can. So it's like then, maybe. Yeah, I think it'd be difficult for us to come up with it, but what it might be is one of these, but instead of s, what might have happened to the s? Shifted. It might be one of these or a combination of these with the s's shifted. Okay. So can we say maybe that what we have 2s plus 1 over s squared plus 6s plus 13, could it be similar to, say, basically a cos? Some combination of a cos and a sine, but with the s's shifted. So instead of s, you have s plus a. Instead of s, you have s plus a. Instead of s, you have s plus a.
Did you leave out the s squared?
Yeah.
On purpose?
Yeah. Just so I have space, right?
I mean on the left hand side there.
It's there now. There, S squared there. Here?
But on the this is up the top. It's S squared plus 2S plus 1.
6s. Where? 2s plus 1. I don't understand.
Oh, I was looking at the other one. Sorry.
No, you're right. I
No,
hadn't-
sorry, I was looking at the question above it.
Alright, okay. So the thing is, could we possibly write this as a combination of those? By the way, just kind of going to where we're going, if you did have one of these, this would be a shifted cos, and this is a shifted sine. Now cos and sines are basically the same thing, they're just ways. So if you had one of these, it would come back as a cos, but the plus a would mean it's shifted. So for example, this yoke here is a cos but shifted, so we must multiply it by this exponential shift. So if we were to send that back, you'd have cos kt times an exponential, negative exponential. What happens to this negative exponential?
It's minus this.